Hi, this is Zach and Issy from Kid2Kid Tutorials, and today we're going to be working on number 3 in our binary video series. The last time we worked on the binary system, and if you don't remember that, the link for the video is in the description below. So now we're going to work on a bit. So a binary digit is called a bit. 4 bits is a nib, 8 bits is a byte. So let's talk about an 8-bit number, or a byte. So we have 2 to the power of 0, which is 1 bit, 2 to the power of 2, which is the second bit, 2 to the power of 1, which is the second bit, 2 to the power of 2, which is the third bit, and so on. So the lowest value for an 8-bit binary digit is 0000000, because all of the bits are false. Therefore, we don't sum up any of the digits. So the highest value is the opposite of that, which is 1111111. And since all the bits are true, we add up all the numbers. So if we had the number, we would add up 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So 8 bits represent the numbers 0 through 255 in the decimal system. That is 256 numbers, because we include the 0 in that. So if you count out all the numbers through 0 and 255, you'll see that there is indeed 256 numbers. So 8 bits is just 2 to the power of 8, which is 256. So 256 numbers. So if there are n bits, you would use 2 to the power of n. So now let's talk about the bit representations. So n bits representation is equal to 2n minus 1. So for example, let's do 3 bits. So n equals 3 bits. That would be 2 to the power of 3 minus 1, which equals 8 minus 1. So the representation for n equals 3 bits is 0 to 7. So the representation of 3 bits is basically the max number that you can have. So in that case, it would be 7. So that's why we have 0 to 7. So now let's look at the possible combinations for n equals 3 bits. So we have 0, 0, 0, which is 0 in the decimal system, and 0, 0, 0, 1, which is 1 in the decimal system, 0, 1, 0, which is 2 in the decimal system, 0, 1, 1, which is 3 in the decimal system, and so on. So now let's go over a few more examples on bit representation. So let's do 1 bit, a 1-bit binary number. So that would be 2 to the power of 1 minus 1, which is just 1. So we would have the numbers 0 to 1. And then let's do a 2-bit number. So that would be 2 to the power of 2 minus 1, which equals 3. So we would have the numbers 0 to 3 in a 2-bit representation. So now let's do 3 bits. So we would have 2 to the power of 3 minus 1, which equals 7. So we would include the numbers 0 to 7. So now let's do 4 bits. So 2 to the power of 4 minus 1 is equal to 15. So that would include the numbers 0 to 15. So now let's go over a question. How many bits do you need to represent the number 6? So pause the video if you think you know this. So the answer would be 3 bits. This is because a 3-bit representation includes the numbers 0 to 7, and 6 is between the numbers 0 and 7. So a binary representation of 6 would be 110, which equals 4 plus 2, which equals 6. So what about 12? How would you represent 12? So you would do, so pause the video again if you know this. So you would need 4 bits because 4 bits includes the numbers 0 to 15. And 12 is between 0 to 15. So the binary representation for 12 is 1100. Thank you for watching Kid2Kid tutorials. And if you like our videos, please share, like, and subscribe. Thank you.